Thanks again for organizing this. I'm super happy and excited to presenting my work to this crowd. And my name is Hande. I am a third-year PhD student at the iSearch lab working with Azzurra Ruggeri. And this is the story of how I ended up in a model reasoning symposium while working on adaptive decision-making and information search. So imagine you are with your best friend, and it's an ordinary day. As usual, you get hungry, and you don't want to lose time, what this and that, and then instead of that, you raise an eyebrow and you say pizza. Or now imagine another scenario that you are on a first date, and again you get hungry as usual. So since you don't know their preferences just yet, instead of suggesting this or that, maybe you would ask this pizza or kebab or whatever. So this is not a dating advice, of course, but if you would apply, this would be a perfect example of adaptive decision-making in daily life. So adaptive decision-making involves flexibly adjusting strategies and questions to meet changing task demands and uncertainty. And being able to take alternative possibilities into account is essential for adaptive decisions. But literature on this, on the development of adaptive decision-making and probability reasoning is a bit in conflict. So, on the one hand, infant studies suggest that babies are quite skilled when it comes to reasoning about possibilities. So they can generate predictions based on the probability structure of the given event. They can adapt their predictions and anticipate future outcomes and prepare for those. And they can maybe even do this A or B, if not A, then therefore B logic. On the other hand, well, unlike infants, it seems like young children fail to show competencies such as distinguishing certain from uncertain outcomes and anticipating multiple alternative outcomes in decision-making tasks. So, for example, maybe versus certain. So in the fork tube task, I am sure maybe you got bored of this task, but here we are. So in the fork tube task, 2 to 4-year-old children and apes were tasked to catch the ball falling from a fork tube. And while considering alternative possibilities would require to cover both ends, children reliably did so only around 3 or 4 years of age. And other research, here's the picture of it, and other research using cups or slides found similar results in which even 4-year-olds sometimes struggle with choosing certain cup or the certain slide. So the contrast between infants' performance and preschool children's performance is indeed a puzzle. But on the other hand, mostly recent research also suggests that there might be actually early emerging abilities, and indeed we can observe this in preschool children. So some other studies, for example, show that children may reason about objects and identities better than locations and trajectories of these objects, or they can generate multiple possible causes from a single piece of evidence, or adapt their information search decision based on the possibility structure of the task. And I will present my work that is built on this final finding. So in this study, we would like to answer, can 2 and 3-year-old children adapt their decision based on the possibility structure of the task? And another question is, do children perform differently based on the temporal structure of this task? And let me open up this a little bit. So we already observed that there's a variety of tasks used in research, like using slides, cups, boxes, balls, and they seem quite different, but mainly all of these tasks do give a set of possibilities, and they ask children to make the more efficient choice based on this certain versus uncertain. All right, but one main difference lies in the uncertainty they provide and the temporality of it. So some of these tasks are prospective, and by prospective I mean the uncertainty is physical. So, for example, when we throw the ball, the outcome is not there yet, so we don't know, but it's also unknowable, so unknown and unknowable. because it lies in the future. And other tasks are retrospective, and here the uncertainty is epistemic, so the outcome is unknown, but actually knowable, but unknown to the child or the participant. And in the literature, the findings are also conflicting. More recent research suggests that there's no such difference because the outcome is revealed in the future anyways, but there's also early findings suggesting that maybe physical uncertainty is easier than the epistemic uncertainty. So these were the questions, and here's what we did. We collected data from 2 to 3-year-old children with an adaptive decision-making task in 2 conditions. One provides a uniform distribution, one is a skewed distribution. I will walk through this. And then we had 2 tasks. One is search and one is catch. Like I said, within subjects and cross-trials. By cross-trials, I mean if a child did the search task in the uniform condition, they did the catch task in the skewed, and vice versa. So, skewed condition. We built 2 different marble runs. This is the marble run that leads to a skewed distribution, or we can also say that this is the necessity one. So in this one, we put blocks in a certain way that when we throw the ball, it always rolls and follows the same trajectory coming from the same exit. Yeah. And the other marble run is the uniform marble run. As you can see, there are no blocks in this case. So when we throw the ball, it's equally likely that the ball can come from any other exit. Yeah. All right. So these were the conditions. Now I'm coming to the tasks. This is the search task. So we placed 4 boxes attached to a cardboard panel in front of the exits, and each box had an opening at the back so that when we throw the ball, they can roll into these boxes. And these boxes were transparent at top, but they were covered by a bigger lid. Yeah. And we introduced 2 actions. One action is taking the lid off. And this is the constraint-seeking action. And constraint-seeking action means an action that targets multiple hypotheses at once. And the other action was opening the box. And this is the hypothesis scanning action, as it can only target one hypothesis, meaning this box at a time. So, and we did 5 times the training, like we throw 5 times the ball, and then each time we ask the child, oh, where's the ball? And then we all sort of encourage them to see that the boxes are transparent, and then they can see at the end the distribution in the uniform and also in the skewed condition. So this is obviously the retrospective task, as they, at the end, we would ask them to search the red ball, while the red ball is already in one of these boxes. All right. So other task is the catch task. So similarly, in the catch task, we did 5 times training. We throw the ball 5 times, and each time we ask the child, oh, where did the ball came out this time? And then after they point, we put a white sticker resembling this white ball to not load the working memory. So at the end of this 5 times training, they can see that, like, how many times did the ball came out from which exit. And again, here we introduced 2 options. One is the small box. Small box can cover only one exit, meaning it can only target one hypothesis, so it's the hypothesis scanning choice. And the large box can cover multiple exits, and thus it's the constraint-seeking choice. So an example trial with expected actions would look like this. In the uniform marble run, we would expect them to lid off the lid to check before opening. And of course, we said that you can only open one box, so that they are encouraged to know before checking. All right, so this is what we did. So we ran a mixed effect logistic regression with condition, age, and months and tasks. And we found a main effect of condition, but no main effect of age and no main effect of task. So we did not find any task difference. But the main thing, that the difference between these 2 conditions, necessity and uncertain were there. But I also wanted to see what each age group did. So this is how the catch tasks were, and this is how the search tasks were. So the interaction effect wasn't significant, but the trend was, in fact, like intriguing enough for me to run a follow-up. All right. So like I said, we run a follow-up to see the catch task only. All right. So before that, we thought about what can we do to make the task better. So we thought maybe it was too easy, or they thought there's a hidden trick when there's the skewed outcome. Maybe they were less engaged, or maybe they were choosing impulsively because we gave them these 2 boxes within the reach. So we did some changes. Instead of a red ball, we said that, oh, this is a fragile glass ball, so you need to definitely catch it. And we put cushions in the boxes, and we placed the boxes on the opposite sides, and we also put the marble run in front on a higher table to emphasize this, it's fragile effect. This time we tested 46 kids. And this is only catch task, so within subjects, catch in uniform and catch in skewed counterbalanced. And this is how it looked like. So we run this time condition and age, and we found the main effect of age and main effect of condition. So children were more likely to choose the larger box in the uniform condition compared to the skewed condition, but they were also more likely to choose this when they grow older. And we didn't find any significant interaction effect. So the condition difference between uniform and skewed, we replicated that one. But we also found this age effect. So I thought maybe it might be due to utility calculus, so maybe older children wanted to show that, oh, I'm big enough to have the big box no matter what. So maybe this cost effect is there. Yeah, but I'm also open to other explanations. So to sum up, even 2 results adapted their decisions to the possibility structure of the task. And I think this checking the different conditions within subject design gives us this opportunity to observe this developmental progress in how adaptively they adjust their behaviors. So even though in single cases they are not performing very well, when we look at these differences, we can see that, oh, there's something going on because they significantly differ their behaviors. And I'm also not given up in this task differences, so maybe we can continue doing this epistemic uncertainty, future uncertainty thing a bit more to make sure that what's going on, whether there's a difference or not. And with that, I would like to say thank you for listening this very late last session, and also my co-authors, Nora, Azzurra, and of course everyone who participated and helped me collecting the data. Thank you so much.